It's quite a bit of power being produced by a device that is way too small to be that, or have batteries involved.
Thank you.
I'm going to show you two devices which have been under development for about 20 years. Both devices are capable of generating electricity, and they're conversion devices. They're not free energy devices. They're not unrealistic devices that can't be properly demonstrated. These devices take energy from the natural magnetic field of the Earth, which has an inherent frequency. These basically tune into that and take the energy that is readily available from the Earth's magnetic field and produce electricity from it. This is a voltage meter. I'll use this voltage meter to demonstrate the power output of one of my devices. This is the smallest device that I've ever made. One of the first devices, because it's put together with baling wire. It's very, very small. You can tell by the size of my hand and fingers that this device is very small. It doesn't contain any batteries capable of generating the amount of electricity that you're going to be witnessing here. Now, I'm going to take this magnet, place this magnet right here. The device is now putting out a consistent 62 volts. Get that in the viewfinder? 61.8. It'll fluctuate back and forth voltage-wise. If you remove the magnet from the system, the voltage automatically starts going down. There's a frequency pattern set up in here, and it takes a while to wind down, similar to a jet turbine. Take the magnet, put the magnet back within the device, and immediately the voltage goes back up again, 61.6, 61.8. If you take this device and hold it in your hands, it vibrates ever so slightly, right around 7.3 cycles per second, and generates a little bit of heat during its conversion process. Now you take this device and, for some unknown reason, turn it upside down. Immediately, it stops producing electricity, down now to 13 volts, 12 volts. It stops producing electricity. Reverse it again, and immediately back up to 61.6 volts. Did you get that in the viewfinder? I have no explanation for why that is. This is the smallest device that I have come up with so far. This device will produce 61.5 volts literally forever. The amount of current that it produces varies. At the present time, at 61.5 volts, it puts out about 25 watts. The more current you draw from the device, the more heat it generates. Now I'm going to show you a larger device I have, also of similar construction. Very, very cheaply put together. There's no mass circuitry involved with any of this stuff. It's just the knowledge of the coils and how they interact with each other. Let me shut it off now and I'll move to the other device. This is my larger device. Again, there's not really a lot to it. We have two conventional lamps here. Regular light here, another lamp here. I'm out of my living room actually. Now this is the device here that I'm going to demonstrate to you. Again, there is very, very little to this device. Wire is very important. Coil operation in here. And if there were any batteries in here, they're very, 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 very small, obviously.
Are there any?
Now, we're going to start the device by again taking two very small magnets, placing them here in the receptors I have for them. This meter here set on zero voltage. It's set at 200 volts DC is the meter range. It's now receiving 0 voltage. Again, this unit is vibrating probably around an inherent vibration right around 6,000 hertz. This is where I monitor voltage output here. And the device is putting out 91.1 volts. Stabilizes 91.1 volts, 91.0 volts, right around 91 volts. Now to show you the current that this device puts out, I need to make a few attachments. This is a 120 volt socket case for the wall, 120 volts. There is nothing inside of here. There are no hidden batteries. The wires here connect directly to these plugs. Set this here, and I'm going to plug this in to the output from the device there. These are 60 watt Sylvania light bulbs. Screwing the light bulb directly into the lamps. Plug this lamp into the outlet there. Plug this lamp. Well, obviously there's 60 watts of electric power here coming from there. Same thing with this model here. There you go. These are regular light bulbs, regular lamps. Okay. When these are lit again, they'll be a little dimmer because instead of 120 volts alternating current, this device puts out 91.2 volts direct current. Actually, it is an alternating current. It's right around 6,000 hertz. But for all intents and purposes, it'll show up as DC. That's why the meter is set on DC. 91.2 volts. So, plug it in here. And voila! We have electricity. And let me get the other one out here. Again, we have electricity. Kind of pan across there and see what's happening. Again, I want to show you that. Move this box over here. I want to show you these wires traveling directly from this device through here into these two lamps where we have two 60 watt light bulbs functioning. 91.2 volts is the constant voltage output according to this meter right here. There's nothing around this machine. These things do put out a little heat. There's nothing anywhere around here on this device that could obviously generate 100 volts of electricity and 120 watts of power. There's no batteries. There certainly is not a computer capacitor inside of this device that could generate this kind of electricity, and not possibly a battery small enough to fit in this device that could possibly generate the amount of electricity necessary to light these two regular electric lamps. So, I thank you for giving me the opportunity to show you this videotape and what I have made so far. I will be producing videotapes of larger equipment that I power with such devices. I have a device slightly larger than this which will operate, puts out about 200 volts of electric power at 20 amps. So as I continue to work on my project, I continue to be able to develop more electric power from the Earth's natural electromagnetic field. Thank you. After viewing the tape, I realized that you can't see very much about this junction box, and you may feel that there's a battery or some kind of a power source in here. So I'm going to try to wire the lamps up directly to this device rather than use this box, so you can be assured there are no batteries or no tricks being played. Again, I'm going to take the light bulbs from this Sylvania light bulb package and put them in the lamps, as I did once before. And show you that, in fact, these lights are functioning the way they're supposed to. There's that one. And there's this one. So, actual lights. And bring these over here to the device one more time. And I'm going to have to try to wire these up manually to the device. Straight from here to the wires from here. Excuse me. I want to be careful so I don't shock myself. There. So, there's one lamp. The other lamp is going to be a little bit more difficult, and I hope I don't shock myself with this, but in essence, there. So you now have both lamps being powered, if you follow the wiring, straight from the lamps, about 120 watts of power at 91 volts. Coming out of this device, straight from these wires. This is the only thing. No boxes, nothing hidden. It's the whole unit, straight from here. As you can see, there's nothing hidden anywhere. So, eliminated the box. And so, thank you. Small enough to fit in this device that could possibly generate the amount of electricity necessary to light. There's nothing anywhere around here on this device that could obviously generate 100 volts of electricity, 1.2 volts is the constant voltage output according to this meter right here. There's nothing around this machine. These things do put out a little heat. There's nothing anywhere around here on this device that could obviously generate 100 volts of electricity, 120. There's nothing